Okay, here's part 3 of our pointers lecture. We are going to dynamically allocate a 1D array. That means at runtime, we're going to specify the array size, right? We've always had to know what the array size was previous to running, right? We had to know that at compilation, but now with a new operator, we're going to be able to dynamically allocate that array at runtime. So we only need to allocate enough memory for our array, right? Now, I'm going through the example I gave you, dynamic array, example 1, right? And let's start with main, right? So here in main, I declared a variable called array size and initialize it to 0, right? And then what I do is I declare a pointer, right? So we're going to create an array of doubles, right? So here in the comments, I'm initializing a pointer to null. Now, we've not talked about that before either. So this is a pointer. I've given it a data type, and there's the asterisk. The asterisk says that this identifier variable name here is going to be a pointer to a double. That's its data type, pointer to double. But I happen to call this array PTR for array pointer. And when you create a pointer, if you haven't allocated memory to it, a safe thing to do is to set it equal to the null pointer. The null pointer is an area of memory that if you and your program try to access that area of memory, you will not be allowed to, and your program will abnormally terminate. But that's much better than if you just left a garbage value in there and you accidentally started using that pointer before you had it pointing to a valid area of memory. You might be overwriting something important. So a safe thing that you'll sometimes see programmers do is to just assign this the null pointer when it's not pointing to a specific area of memory, right? All right, so now that we've initialized this the null pointer, what we're going to do is we're going to prompt the user to enter the array size. So I've written a function called getArraySize. It's going to return the array size here, right? So let's take a look at that function. We'll scroll up. Here's my function, getArraySize. It requires no parameters, right? No arguments. I set a variable named m, right? I'm going to prompt the user to enter the number of array elements. We're going to try to read that number in and store it in n, right? Since I'm using cin and I'm trying to read an integer, I want to make sure that it doesn't fail to read. So this function has a while loop, and this while loop is going to execute until we actually get the user to enter an array size. So if an integer value for array size. So if the user successfully enters array size here, an integer value, right, this fail option will not be true, and our code will drop down here. But if the user types some non-numeric data that it can't recognize as an integer, right, cin.fail will be true. And we'll go ahead and print out an error message. We'll clear the fail bit, so we have to clear the stream flags. And then we'll remove the garbage from the stream. We've done this in other examples. We're going to remove up to the maximum number of characters or until we encounter the enter key press, right? So once we've removed any sort of bad data from the stream, the data that made this fail, then we'll prompt the user again to enter the number of array elements. We'll try to read that in. As long as this fails, right, this will keep executing. When the user finally manages to enter an integer value, then we're going to return that. Before we return that, we're going to remove anything else the user types. So remember, when cin reads a value, that enter key press is still out in the stream. Also, if the user maybe types some other garbage after that, let's clean this up. We want to guarantee to our users that when this function returns, the cin flags are in a good state and that we have removed all the data from the stream. So finally, this will return a value of n. Right. So the value it returns we know is an integer. So let's go back to main. So in main, we called the function getArraySize. Here then, we have something stored in here that we know the user typed in that value. Now, we don't know if it's a positive or negative number, right? For an array size, we should have a number, a positive number, right, that's greater than 0. So there was nothing in our function that guaranteed it was within a range. So here, I've got a while loop saying while array size is less than or equal to 0, right, we're going to tell the user that the array size must be a positive value. We'll just let this sleep for half a second, right? So this message is going to pop up really kind of quickly, right? We'll pause for a second. Now I'm not clearing the screen, so this will stay up on the screen, but we'll call get array size again, right? So as long as the user keeps entering something that's not a valid array size, a positive number, our program will not end. It will just keep prompting the user, right? Right. So let's go ahead and do a run to cursor to see that in action. All right, so this pops up and says enter the number of array elements. Well, if I actually type in, so I'm going to type a capital Y, hit the enter key, right? We get our error message, non-integer data type error. So let's go ahead. If we type in something like -1, right? That is an integer. Our function will return, right? But we come back here and we see that array size must be a positive value. So we hit that. We prompt the user to enter something again. And now let's just say we want an array of 3 elements. I'm going to hit 3. All right, so now back in main, right, if we look at array size has the value of 3. What we want to do now is we want to allocate an array of doubles, right? So array pointer, that's a pointer to a double, right? In order to allocate that array, right, so we're allocating it at runtime using the array size that the user input. So we're going to assign to that array pointer a memory location. We use the new operator. You use the standard no throw constant. Remember, no throw will not throw an exception. What will happen is if it can't allocate memory, it will store null pointer in here. And we're going to ask it to allocate an array. So in previous examples, we just tried to allocate a single integer, right? But when we want an array, we still have the data type. We use the bracket notation, and in here, we put how many elements we want in the array. Well, our variable array size contains that. So what this will do, this will allocate enough memory for an array of 3 doubles. 3 because that's what I stored in array size. Right, so if I hit F10 and I accidentally hit F9, F10, that allocated that, right? And so now we're going to check, right? In case this failed to allocate it, we would want our program to terminate. So if I hit F10, we can see that condition was not true. So it did not print out that message, right? We've got an address here for array pointer. Right, now we want to fill the array. So in this example, we're just going to fill the array with some random values. So I'm going to call a function called fill random double. We're going to pass to that our array pointer and the array size. Right, so I'll hit F10. And I didn't mean to hit F10 because that actually executed this function. Let me stop the debugger. All right. Let me do a run to cursor here. So let me go back and enter R3. All right, F11, so I can step into the function. All right, so what this function does is I wrote it to fill the array with random doubles in the values in the range of 0 to 1. All right. So you can see then this has 2 parameters. Notice we have different notation. We don't have the bracket notation now. Because this array, right, is an array of doubles, we have a pointer to double. Right here, the identifier name is ARR, and then N is the number of elements in the array. Right, we normally have to tell a function how many elements are in the array. All right, and so what this is going to do is this is going to loop through. So, right, in previous examples when we dealt with statically declared arrays, so statically meaning at runtime, then we would use this bracket notation, right? We would have done this, right? Well, now that we're using a dynamically allocated array and a pointer, we do not use this bracket notation, right? So I'm going to get rid of that, right? That was just to remind you of the old notation. But what's nice is since this is an array, since this is a pointer to this, we can still use the index notation to allocate elements. Right, now there are other ways to use the dereference operator with a pointer to access memory. We have a limited amount of time in this course that usually ends up confusing students when they're new to pointers. So in my examples, I'm just going to use the indexing element. right? And so we haven't talked about pointer math and things like that yet. So we're going to use our familiar indexing element. And that's what I would recommend that you use in this class, right? We have a lot of other material to cover, and we'd have to probably spend a lot more time and work with pointers a lot more till you got used to the other notation. All right, so you can see here, just got a loop, I equals 0, I less than n, right? And we're going to loop through one at a time, and we're going to store in our array at index location I. Well, in order to get doubles, all I did was call the rand function here. Remember, rand returns a value between 0 and rand max. I cast that to a double, and then I'm going to divide that by rand max. And that's how we guarantee that we'll get something in the range of 0 to 1, right? If this were to return rand max divided by rand max would give us 1. Otherwise, it's going to return a value less than that, right? If this were to return 0, then we'd have the value of 0. All right, and that's how I'm just making an array of quote doubles that are in the range between 0 and 1. All right, so when this function finishes, right, our array will be filled with random values. All right, so let's just go ahead and let's see, I can't remember. I guess build error, sorry. That's because I typed in this other stuff. Let's just go ahead and do a run to cursor here. Right, this should rebuild. It's because I typed in that other static stuff. All right, so I want 3 elements again. Right, F11 to step into the function. Right, now that we're in here, right, locals ARR. Right, we can't really see what's in memory. There is a way to see what's in memory. All right, so here in this function, the name of my array is ARR. I think if I type the name of the array plus 0 for the index, and then if I say go to n, this doesn't know what n is. All right, I'm going to type the 3. All right, and so we can see what the elements are. All right, so if you want to see what's in an array in the watch window, right, and you're dealing with pointers, we weren't able to see that before. We could only see back here under locals. It will only show us here what the first element is. So here, if we use the name of the pointer in parentheses, when I say plus 0, that means start at the beginning of the array. We're pointing to the beginning of the array. This relates to that, to some pointer math. And comma 3, that says how many of these array elements I want to see. Well, I said 3 because I know we have 3 in our array. So here in the debugger, it's going to show me what's at index 0, index 1, and index 2, right? That helps us see the memory location when we're dealing with pointers. All right, so now I'll just hit F10, right? We'll step through here, and you can see, right, array at index 0 just got a value, right? Array at index 1 did, array at index 2, and now we're done with our function. All right, we come back here. Now, because we passed a pointer, very similar to a reference, we affected memory outside of our location, right? Pointers point to other addresses of memory. So we were able then to change the memory that we allocated back here in main, right? So back here in main, right, this doesn't know what ARR is, right? It actually knows what array pointer is, but once again, it only shows us the first variable. So here, if I were to, I'm going to delete that. Here, if I just say ARR, PTR, that's the name here, main plus 0, right? This says that the plus 0 is an offset location, and comma 3, hit the enter key. All right, and so now you can see back here in main, this is the name of the pointer that refers to that area of memory, but you can see the 3 addresses in there. All right. Now, the other thing we need to do in this example, right, before our program ends, we need to delete the memory. And when we have created an array, we still use the delete operator, but we use delete with the empty bracket notations and then the name of the pointer. All right, remember, if we just created a single variable, we just use delete without the brackets, but now with the array, we use the bracket notation. I just noticed I left out my return 0. All right, so with the array, we have delete in the bracket, right? So to summarize, right, we created a pointer to a double. We set it equal to a null pointer, We queried the user for the size. We made sure that the size was a positive number. And then to allocate an array, right, new operator, standard no throw, data type, inside the brackets, we say basically how many doubles we want, right? When array size was 3, we got 3. That allocates enough memory for 3 doubles or whatever array size happens to be, right? Array pointer points to the beginning of that memory location, right? We check to make sure that that memory was allocated. If it's not, our program's going to print an error message and terminate. Otherwise, if it was allocated, we went ahead and we filled the array with random numbers. All right, remember then, sorry, this notation now, we have the pointer notation here. When we call the function, we still just call with the name of the array. And the other important thing is when we've allocated an array, right, multiple doubles, then we use delete with the empty bracket notation and the pointer name. So there's some new syntax for us to learn, right? But that's how we can create then an array of that depends on the size entered at runtime, right? We might not always be asking the user, we might be reading data in from a file and be able to dynamically allocate that. So we refer to these as dynamically allocated arrays, right? And that's how we do it for a one-dimensional array. Our final lecture will be on how to handle 2D arrays.